Alright, this is your Unit 4 Inequalities and More Study Guide video. Let's get started. Question 1, we start off with k minus 3 is less than 2. So we're going to solve an inequality the same way we solve equations. We want to get the variable all by itself. So to get rid of a minus 3, we're going to add 3 to both sides. And you're going to get k is less than 5. Now a way to check this, just like with equations, is you can plug a number back in. So this says k is less than 5, so pick a number smaller than 5 like 2. If you plug 2 in, 2 minus 3 is less than 2, it is. So check, it's right. So you can still check these just like equations, and it takes you a good 5 seconds to check them, so it's worth it on the test. Now the next part of this question wanted us to graph it. So we're going to make our number line. I don't care about how fancy you make it, so I'm going to make this very basic. I'm going to put just the number itself on the number line. Then I'm going to do some shading. This says the answers, which are k, are smaller than 5. So no matter where you're at on a number line, if you want to make something smaller, you have to travel to the left. So you're going to shade to the left. Now the number 5 doesn't work. It says it's less than 5. Because if you put 5 in here, you get 2 is less than 2, which is a false statement. So at the 5, you have to put an open circle. Okay, this is open and not shaded. So that means if you were to plug 5 in, it's not going to work. That is what we call the boundary number. It separates the answers from the non-answers. All right, on to question 2. We have 3x plus 24 is greater than negative 5. So our standalone number is 24. So to get rid of a plus 24, we subtract it. And so now we have 3x is bigger than negative 29. The 3 is a multiplier, so we divide. 3 won't go into it evenly, so I'm going to keep it as that nice improper fraction. So now we go into the number line. The only number we care about is this negative 29 over 3. Whatever that might be as a mixed number, doesn't matter to me. This says x is bigger because it's getting chomped by the arrow. So to get big numbers, you go to the right. So here's my initial starting point. So now I'm going to go to the right. So I shade everything to the right. The number itself doesn't work, so I'm also going to leave that arrow as an open circle. On to number 3, where it gets a little bit more confusing, more steps. We have negative 1/4 y plus 9 bigger than or equal to 3. Now there's a lot of ways to approach this, but you know I always like to do fraction busters because I don't want to work with fractions. So if I multiply 1/4 by 4, the 4's will cancel out. And again, just to show that, if you do 1/4 times 4 over 1, you get 4 over 4, which is just 1, which is the number that's on the top. So I like to just show the cancel out process like that. So now you're left with a minus 1y. Now since I decided to alter their equation or their inequality, I have to do it to everyone. And that's the step that a lot of people will forget, is to multiply all the numbers by the 4. So you get 36, and then you get bigger than or equal to 12. Now we're ready to play the game of opposite. So to get rid of a plus 36, I subtract 36. So you get negative 1y greater than or equal to, that's going to give me a negative 24. Now we can't tell someone what the negative answer is, so we have to get rid of that negative 1. It's touching the y, so that means it's multiplying. So I'm going to divide by negative 1. And then this is where the bells, alarms, whistles go off. When you divide, when you bring over a negative to divide with, which is what I've just done, I brought over a negative to divide with, that arrow flips on you. It turns the other direction. And so that's the only new thing that we learned in inequalities in regards to solving them, is sometimes you have to flip the arrow. And we'll do the number line really quickly. 24, we're less than, so we're going to be to the left of 24. We also have this equal part underneath, which means I've got to bubble the 24 in, because 24 actually does work. On to question 4. We have 3 parentheses. I'm going to use an x instead of t, so it doesn't look like a plus sign. So I'm going to say 2x minus 5 plus 7 greater than 8x plus a 2. So can't play the game because I got pieces trapped inside of the box. So we're going to use that distributive property to get them out. 3 times 2x is 6x. 3 times a negative 5 is a negative 15. And I'm just going to rewrite the rest of the problem. Then I'm not organized. This negative 15 and this plus 7 should be put together. So negative 15 and a positive 7 is going to make a minus 8. So now everything has been organized, but we still can't play the game of opposites because we've got variables on both sides. So to get rid of those, we choose a side to get rid of the x's, either the left or the right. I'm just going to get rid of these 6 x's here. So if you have 6 x's and you don't want them, take them away. And then we'll do the same thing to the other side. We'll take them away. So I've got negative 8 is bigger than 2x plus a 2. Now we can play the game of opposites. So we get rid of our standalone number, so we subtract 2. We get negative 10 is bigger than 2x. 2 is a multiplier, so I divide. And at this point you might say, so we flip the arrow. No flip. There's no flip on this one because we brought over a positive to divide with, not a negative. So it just stays x is less than negative 5. There is no flip to it. And then if we make a number line, put a number at negative 5, put an open circle that says it's smaller. So to get smaller, you move to the left. All right, on to our word problems. Number 5 says the product of a number and 7. So product means multiplication. So 7 times a number could just be 7w. And then it says is at most. So I'm not really sure what symbol to use yet, so I'm going to come back to that. Then it says the difference of the number and 5. Difference means to subtract, and they say subtract the number, which is w, and 5. So now let's go back to this word at most. They're saying 7w is at most. So just like if I said I'm going to give you at most 10 questions of homework, I'm not going to give you 10 questions or more. I'm going to give you at most 10. So you're going to have 10 or less. Just like if you've got to have at most something, you can't go over that number. Now we go into the solving. Remember, there's really a 1 in front of here if that helps you. We've got w's on both sides, so we're going to subtract 1w and subtract 1w. So I'm left with 6w is less than or equal to negative 5. Now to get rid of that 6, it's a multiplier, so I divide. Again, there is no flip because you brought over a positive. You didn't bring over a negative to divide with. And we don't have to do any graphing on this one. So we get our variables less than or equal to negative 5, 6. On to number 6, you're selling tickets for a play. You want to figure out how many tickets do you have to sell to make at least 50. So you get $3 for every ticket. You want to have at least $50. So the money has to be bigger than or equal to. Just like if you go to a carnival and they say you must be at least this tall to get on the ride, you have to either be that height or taller than that. Now we can solve it. Divide by 3, divide by 3, and you get x is bigger than or equal to 16 2/3. But you cannot write that as your answer. Because can you sell 16 2/3 tickets? No. So your goal is, well, what do I do? Do I sell 16 tickets or 17? Well, if you sold 16, you would only get $48. So you have to sell more than or equal to 17. 17 tickets is the magic number in order for you to make your goal of $50. Now we get to the parts where you do the translating. So you've got a number line, you've got 0 here, you've got a 2 here, and then it shades here, and then it shades. So this is a compound inequality. So all you have to do is translate what you see. You've got 2 numbers, so you make a statement about each. The numbers, the shading is to the left of this 0, which means your numbers are smaller than 0. On this side, your numbers are bigger than 2. And since you're using 2 inequalities, you have to pick a word. And the 2 words that you choose from are and or. You always check and first. Always, always check and first. Can you be smaller than 0 and bigger than 2? You cannot, which is why you use the word or. Ors will always work in any scenario. So that's why you can't just automatically put that, because if an AND works, that's the one that you have to stick with. So you always check AND first. Check AND first. All right, number 8. Got another number line. We got 0 bubbled in to the left, and we've got a 1 not bubbled to the right. So again, we translate. This shading is to the left of 0. So n is less than or equal to, because it's bubbled in, 0. These numbers are to the right of 1. So the numbers are bigger than 1. So again, we check AND to see if it works. Can you be less than 0 and bigger than 1? No, it's mathematically impossible. So this has to be an OR statement as well. And that is your first page. Now we're on to our second page, where we go back into the solving part. So this is number 9. We have 4 is less than 3x plus 3, which is less than 8. Same concept, except now you've got 3 sides. Or 3 parts. You got the left, you got the middle, you got the right. Goal is still the same. Get the x by itself. So to get rid of a plus 3, you're going to subtract 3. And you're going to do it to all 3 sections. And now let's see what we have left. 4 take away 3 is 1. Your 3x is all that's in the middle. And you have a 5 on the right. This 3 is a multiplier, so we're going to divide to get it out of there. And we're going to divide all 3 sections. So you get 1/3, get x, and you get 5/3. And that's your answer. Except now we actually have to graph this as well. So now our graphs, when we make them, are going to have 2 numbers on it. The smallest on the left, the biggest on the right. And what you're going to do is you're going to check all 5 parts. Because you got the left, the middle, the right, and the 2 numbers themselves, which make 5 parts. So we're going to pick a number from over here, something to the left of 1/3, like, I don't know, -8. And now see if it works. Is -8 bigger than 1/3? It is not, so we cannot use the left-hand side. So then I'm going to check 1/3. Plug in 1/3. Is 1/3 bigger than 1/3? It is not, so I'm going to keep it open. Now plug a number in the middle, like 1. Is 1 bigger than 1/3? Yes. Is it smaller than 5/3? Yes. So since it works in both of these, since it works in both problems, we are going to shade the middle. Then we check 5/3. Is 5/3 bigger than 1/3? Yes, it is. But is it also smaller than 5/3? No, it is not. And since it didn't work in both, we cannot use it. And then the numbers to the right also are not going to work. Like if you pick a million, 1 million is not smaller than 5/3. So this one only shaded the middle. Now we're on to number 10. We have g minus 6 is greater than -1, and 2g is less than, just less than 6. So here we go. We're going to add 6 to the first one. We get g is bigger than 5. Don't forget to bring down your word and, it's crucial. Divide by 2, divide by 2. G is less than 3. So we've solved it. Now we go to the number line. 3 is the smallest number, so we plug it in first, then 5. Now we check this different sections. So a number to the left of 3 could be -2. -2 is bigger than 5. No, it is not. And since this is an AND statement, I automatically don't even check the other one because it has to work in both. So now I check out 3. 3 bigger than 5. No, it's not. So I move into the middle, like 4. 4 bigger than 5. Nope, so the middle doesn't work. So now I check out 5. Is 5 bigger than 5? No, it does not. Now I pick a number to the right of 5, like 7. 7 bigger than 5? Yes, so finally. But wait, and 7 is less than 3? No, it is not. So this is a no solution. It is impossible if you said, bring me a number from the back that's bigger than 5 and it's smaller than 3, you would have no numbers to pick from because it doesn't work. All right, 11. Let's see what we've got for this one. We have 4x plus 2 greater than or equal to 10, and x minus 10 is less than -2. So let's solve. Subtract 2, subtract 2. 4x is bigger than or equal to 8, divide by 4, divide by 4. X is bigger than or equal to 2. Don't forget to bring down your word and. Let's solve this one. Add 10, add 10. We get x is less than 8. And now we do the number line. So we've got 2 is the smallest number, 8 is the biggest. Pick a number to the left of 2 like 0. 0 is bigger than 2. No, it's not, so we don't use the left. Now we check out 2. 2 is bigger than or equal to 2. Yes, it is. And 2 is less than 8. Yes. Because it worked in both, that means I use it. Pick a number in the middle like 6. 6 is bigger than 2. Yes. And 6 is less than 8. Yes. So that means we're going to use the middle section as well. Now I check out 8. 8 is bigger than 2. It is. 8 is less than 8. No, it is not. So I'm not going to use an 8. And then pick a number to the right, and you'll see that it doesn't work in the x is less than 8 either. All right, number 12. We have x minus 3 less than 6, or 4x less than or equal to negative 16. So we add 3, we get x is less than 9. Divide by 4, divide by 4. No flip, because we didn't divide with the negative. We brought over a positive. So we have or, and this is x is less than or equal to negative 4. Now we've got to do our shading. We have an or statement, so it only has to work in one of them if we're going to shade. So pick a number to the left of negative 4, like negative 30. Negative 30 is smaller than 9. It is, so I can shade it right away. So it's an or statement. If you're an or statement, you only have to work in one of the inequalities. Plug in negative 4. Negative 4 is smaller than 9. Yes, it is. So I bubble that in. Pick a number in the middle, like 1. 1 is less than 9. Yes, it is. So we bubble the middle, shade the middle. Now let's take a look at 9. 9 is less than 9. It is not. But let's check the other one. 9 is less than negative 4. It is not. So we're going to keep that open. And then we pick a number to the right of 9, like 80. 80 is less than 9. No, it's not. 80 is less than negative 4. Nope. So you shade the left, the middle, and the negative 4 itself. 13. Speed limit. Every road has a speed limit, and the speed limit on this road is 55. But no one drives exactly, not all cars will drive exactly 55 at all times. So this police officer says, I allow people to go over 50 miles. So, go over 5 miles. So you can go over 5 miles per hour and not get a ticket. Or you have to make sure you can only go under 10. Because if you're driving super slow on the highway, you're going to cause wrecks as well. So they say as long as you're under 10 miles per hour, no ticket. So our goal is to figure out, well, what speeds can I actually move at? So I'm going to use S for my speed. So my speed has to be, if 55 is the limit and I can be under that by 10, 45 is the smallest that my speed can be. So my speed has to be bigger than or equal to 45 miles per hour. Now let's figure out how fast we can go. He lets me go 5 over the speed limit. So I'm allowed to go over 60 miles. So my speed has to be bigger than 45 and smaller than 60. Anything else? So this is an and statement. Even though I didn't write the word and because I chose to write it as one big inequality, it is an and statement. 14, on to our absolute value questions. We have the absolute value of 3w minus 6 is equal to 9. Now again, remember, we're going to solve for w, but don't worry about that at the beginning. Ask yourself, if this was covered up, what number do you need from here? You either need a 9, because the absolute value of 9 is equal to 9, or you need a negative 9, because the absolute value of negative 9 is a 9. So when we actually see what's behind here, and we see it's a 3w minus 6, well, that just says, okay, make that 3w minus 6 give you what you wanted. You wanted a 9, or you wanted a negative 9. Now you can solve them. Add 6, add 6, add 6, add 6. So I have 3w equals 15. 3w equals -3. To get rid of that 3, it's a multiplier, so we divide, 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 and I get 5 as well as -1. Those are the two numbers that work. And if you don't believe it, plug 5 in for w and see what comes out. You'll get a 9. 15. This one. This one's different because you have absolute value of 2x plus 5 minus 7 equals 38. So you can't say what you want this to be right now because the absolute value doesn't equal anything. This says the absolute value minus a number is equal to something. So let's get rid of that minus a number so we can figure out what the absolute value needs to be. So get rid of a minus 7, we're going to add 7. So I get absolute value of 2x plus 5 is equal to 45. Now you can make a determination. You're saying, what do you want behind here? What has an absolute value of 45? Well, 45 has an absolute value of 45, and negative 45 has an absolute value of 45. So that's what we want. Well, they didn't give us that. They gave us 2x plus 5. So that's what we make 2x plus 5 give us. Give me a 45, or give me a negative 45. And then we can solve them. So subtract 5, subtract 5, subtract 5, subtract 5. Get 2x equals negative 50. 2x equals 40. And we're going to divide by 2, divide by 2, divide by 2, divide by 2. And I get 20. And I get negative 25. And those are my answers. Now, one thing you do need to make sure you're aware of, this isn't on the study guide. If you had the absolute value of something in here is equal to negative 4, you would say no solution. Because you can't put a 4 in here and get, this is saying distance is negative. There's no such thing as distance equaling a negative. So just make sure you're aware of that if that happens on the test. Alright, 16, word problem. So we have Sloan and Olivia. They are putting on frogs. They need to put at least 5,000 pounds of frogs. So I'll put at least 5,000. And it says they loaded, it says it loaded 2395. And it says that there was a mistake. And the mistake is that 50 of the 2395 is 2345. Hold on one sec. Do it through their teams. I don't have my computer here, that's yours. I don't want it's already full. So I don't want, yeah. Yeah. Okay. Alright, we're back. Sorry for the delay. So 2395, but there was actually 50 of that weight was from some equipment. So there was really only 2345 of frogs on the truck. So now let's see what we've got. We got 2345 of the frogs, which we're supposed to have 5,000. So we need to add more frogs to get to 5,000. And once we add this weight, the weight has to be bigger than 5,000 or equal to 5,000. So now what we're going to do is solve it. Subtract 2345 from both sides. And now you say, okay, frogs-wise, they need to load at least 2,655 more. As long as they load that or more, they have hit their goal. Alright, 17 is a little bit of review. You had to remember how to find the average of numbers. So to find the average of numbers, you add them all together and divide by how many there are. So the numbers we have for this show are 105, 191. But there's going to be a fourth show. So we have to add in this random fourth show. And they say they want the average of these four shows. So 1, 2, 3, 4, which means I have to divide my answer to the sum by 4. Now they want the answer to be between. And on your study guide, I highlighted, I bolded and underlined between. Between means you can't equal those numbers. So you have, this average has to be bigger than 100 and smaller than 120, not equal to. If we would have used the word inclusive, inclusive means that you use the greater than, equal, less than, or equal. But we didn't say inclusive. We used the words between. So now let's actually solve it out. 105 plus 100 plus 91, we're going to add those together, and that is going to give us, we have 100 is less than, we've got 4, that's going to give us 296 plus x is less than 120. Now we can solve. This 4 is a divider, so to get rid of dividers, we know that we multiply, so they will cancel each other out. And I got to do it to all 3 parts. So I get 400 less than 296 plus x less than 480. Now we can get rid of the 296 by subtracting 296. And so for our fourth show, we need to have more than 104 show up, but less than 184 to show up. If that's true, when we find the average, we'll have hit our goal of being between either 100 or 120. All right, 18, we got a Hawaiian vacation. We're going to rent a car. So there's 2 cars to choose from. You have part A, option A, and you have option B. So you want to save money, so you want to figure out your bill, or maybe you don't trust the person running the cash register. So if you want to figure out your bill for option A, it says you pay $25 a day and you pay 15 cents a mile. And you're only going to rent the car for 1 day. So the $25 is going to stay how it is. But we're going to add 15 cents for every mile that you drive. So if you tell me the amount of miles, I plug in miles, do the math, and I get you my bill. Option B is a little bit different. It's a less daily fee, but you pay more for your mileage. So this is where if you knew how many miles you were going to drive, you could pick the better option so that you actually save money. And so part B says, or part A, we want option A to be cheaper. So if this is going to be the cheaper plan, that means the bill has to be smaller than option B bill. And now we actually solve it in the second part. So let's get the m's on one side. So subtract 0.15 m. So we have 25 is less than 10 plus 0.25 m. Now we get rid of that 10 because that's our standalone. So subtract 10, subtract 10. So you get 15 is less than 0.25 m. And then we got to get rid of that 0.25. It's a multiplier, so we're going to divide. And 15 divided by 0.25 is 60. So if you're going to drive over 60 miles, you would pick option A. If you're going to drive under 60, option B would be the better for your budget. All right, and finally, we are done with the inequalities part. Now we're going to move into the radicals part. So 19a says take the square root of 7 plus the square root of 3 plus the square root of 98 minus the square root of 18. You can't do this. This would just be like me asking you to do x plus y plus w minus z. They're all completely different. But we can't just say, well, we can't do it, move to the next question. What we have to do next is we have to try to erase this if it lets me. There we go. Lagging. We have to simplify our roots. So 98 we can simplify. I'm going to use the factor tree method because that's what most people have been using in class. So if I take 98 I break it down to two numbers that multiply to 98. It could be any two that you think of. So I think 2 times a 49. Then I break 49 to 7 and a 7. I can't go any further with that because now I would just use ones. So I could rewrite square root 98 like the following. 7 times 2. That gives you your 98. But now look what has happened. You see that you know what 7 times 7 is. That's a 49. And you know what the square root of 49 is. It's a 7. So this turns into 7 root 2. Because we couldn't take the square root of 2, so it stays underneath. Now I'm going to do 18. So break 18 down to 3 and 6. 6 I could do 3 and 2. So now I'm going to rewrite these. So I've got 2, 3, 3. So 2 times 3 gets you right back to your 18. Now look for numbers to multiply to get something that you know the square root of, like 3 times 3. 3 times 3 is 9, and the square root of 9 is a 3. So now you have minus 3 root 2. You have your plus 7 root 2. You had your plus root 3, and you had your root 7. Now we can do some work, because now I can add things together. I've got a 7 root 2, which is just like a 7x. And I have a minus 3 root 2, which is just like a minus 3x. So 7x minus 3x is 4x, but I'm not going to write x, I'm going to write down that it's root 2. And then plus root 7 plus root 3. So we see that radicans have the same rules as variables do. Alright, moving on to part B. We start off with 3 root 5 minus 3 root 11 plus 2 root 121 minus 3 root 90. Can't do any of this. They're all different. 5, 11, 121, 90. So we need to have the same, you always have to have the same radicans if you're going to add or subtract. Let's see if we can simplify anything. I can do this because the square root of 121 is actually just an 11. So this is 2 times 11, which is 22. I can't simplify minus 3 root 11. Can't do anything with 3 root 5. But I can do something with 3 root 90. I can take 90 and break it down. So 90 could be 9 and 10. 9 could be 3, 3. And 10 could be 2 and 5. So now I've got minus 3. Put all my numbers in here. So 2, 3, 3, 5. I see that if I multiply 3 and 3 together, I get a 9, and the square root of 9 is a 3. But there's already this 3 out here. So that means they're touching, which means they end up multiplying. You didn't do anything with the 2 and the 5, so they need to multiply to make 9 root 10. So you have 3 root 5 minus 3 root 11 plus 22 minus 9 root 10. And nothing can be simplified after that. Nothing be put together. So we have our answer. Now on to 20. To do 20, first have to remember something from our previous units. If you have a base and then it has a fraction exponent, this number on the top becomes the exponent in the new answer, and the number on the bottom becomes the index. So remember, this is how you would write it. Base, this number on top becomes the exponent of that base, and this number on the bottom becomes the index. So if you add x to the 3/5, it would have turned into x. 3 is the exponent, 5 is the index. Exponent top, index for the down. And an index just tells you how many times you're going to multiply with your root. So if I said the third root of 8, I'm saying what number multiplies 3 times to give you an 8, which in this case we know what that one is. That would give us a 2 times a 2 times a 2. So here we go. Let's transfer all of these from, let's put them how they started off with. 8 to the 1/2 plus 16 to the 1/4 minus 12 to the 1/2 plus 81 to the 1/4. So here's the transfer. 8 is the base, exponent is 1, index is 2. 16 is the base, exponent 1, index is 4. 12 is the base, index 1, index is 2, exponent 1, index is 2. and 81 base, exponent 1, index 4. Now let's clean this up a little bit. 8 to the first is just an 8. 2 is the index, is what it always is. That's the definition of a square root. So you don't have to put the 2 there. You can if it makes you feel more comfortable though. This is the fourth root. 16 to the first is 16. I don't need the 2 in front, so I just put the 12. And then here, this was the fourth root of 81. Can't put anything together. So now let's do some simplifying. I'm going to switch over to the perfect square method since I did the factor tree on the last two problems. Perfect square method says what two numbers multiply to give you 8. Just make sure you pick something you know the square root of. So I could do 4 times 2. 4 times 2 is 8. Square root of 4 is 2. So that's just 2 root 2. This says what number multiplied 4 times gives you a 16? 2 does. 2 times 2 is 4, times 2 is 8, times 2 is 16. Minus 12, don't know the square root, but I could break it. And I could do a 4 times a 3 since I know the square root of 4, so that's 2 root 3. And this says the fourth root of 81, what number multiplied 4 times is 81? That is a 3. So now we simplify. Positive 2 minus 3 gives me a negative 1, plus 2 minus 2 root 3. Alright, on our next one, you can look at the study guide to see what they started off as, but it's going to become 8 square root 2 minus the cubed root of 27 minus the square root of 3 plus the square root of 128. So let's see what we can do. 8 root 2, can't do anything with it. Cubed root 27, yes, that's a 3, because 3 times 3 is 9, times 3 is 27. Square root 3, can't do anything with it. 128, we can simplify that a little bit further. So the first thing that comes to mind is I see that a 4 goes into it. So that would be a 4 times a 32. The square root of 4 is 2. So 2 root 32. But now root 32 can be broken down. I can say 4 times 8. So the square root of 4 is 2. So now you have a 2 and a 2. What do? They multiply. So you have 4 root 8. I can go even further. Root 8 can do another 4 again. It's 2. Square root of 4 is a 2. So 4 and 2, what do to each other? They multiply. So you get 8 root 2. Now we see, can we combine anything? Yes, we can. 8 root 2 plus 8 root 2 is 16 root 2. Minus 3 minus root 3. And you've got your answer. And finally, last page is asking us about rational and irrational. And if they're always true, sometimes true, or never. So you're going to have to look on your study guide because I'm not going to write these out. I'll talk about them, but I'm not going to write all the words. So one says if you add two rationals, you always get a rational. That's always true. You can never add two nice numbers and get a crazy decimal when you're done. Because remember, there's only one kind of irrational. It's a never-ending decimal that has no specific pattern that goes on forever. And where do irrationals come from? They come from roots that we don't know the answers to right away. Number 2, the sum of a rational and an irrational is irrational. So normal plus crazy decimal always gives you a crazy decimal. Yes, that's always true. Number 3, the sum of an irrational and an irrational is irrational. So a crazy plus a crazy gives you another crazy. Yes, always true. And a way to think about that is if you're going to add pi plus another pi. And on number 2, where it was rational plus an irrational, if you do 2 plus a pi, you're still going to have the crazy pi decimal when you're done with the problem. Number 4 says the product of rational and rational is rational. Yep, always. 2 times 3 is equal to 6. You can never multiply nice numbers and get the crazy decimal. Number 5, the product of rational and irrational is irrational. Okay, so rational times an irrational. So like 3 times a pi. Well, that would give you 3 pi, which is going to give you the craziness. So yes, that's true. But what if I chose 0 as my rational number? 0 times pi gives me 0. So sometimes I get irrational, other times I get rational. So this is a sometimes statement. So you always need to check 0 out when working with rational numbers. And finally, the product of an irrational and irrational is irrational. Well, that's true. Square root 3 times the square root of 5 would be the square root of 15. That's irrational. But if I did root 3 times root 3, I get the square root of 9, which is equal to 3, which is rational. So this is a sometimes statement as well.